All right, guys. So we're going to evaluate inverse trig functions. Inverse trig functions, your x's become your y's and your y's become your x's. That's how inverses roll. Really pay close attention to these. I'm just going to show you. I'm going to show you one slide with some definitions. The rest of our examples. Really watch those slides carefully. All right, guys. I'm going to give you the nitty gritty here on these inverses. We're going to start with inverse sine. With inverse sine, you're only allowed to use quadrant 1 and quadrant 4, and that is all. Your answer must come from one of those. And basically what's going to be backwards is, first of all, look how it's written. So we'll sine with a little -1 usually, like sine -1, and it may say square root of 2 over 2. And what that's asking you is, where is sine square root of 2 over 2? Well, because it's positive, it's somewhere in quadrant 1. Now, if it was a negative square root of 2 over 2, it'd be somewhere in quadrant 4. Okay, so instead of asking you what is sine pi over 4, they're going to ask you where is sine square root of 2 over 2, and you would say, oh, it's at pi over 4. Okay, so it's going completely backwards of what we've been doing. But for sine, inverse sine, quadrant 1 and 4. Inverse cosine, look at the difference, quadrant 1 and 2 only. And because this is why, remember, cosine is x. X is positive in quadrant 1, negative in quadrant 2. So if it's a positive cosine, we're looking at quadrant 1, inverse cosine, I should just say. If it's a negative inverse cosine, it's quadrant 2. So if you see something like this, where's cosine? So it would be written like that. Where inverse cosine 1/2 means where's cosine 1/2? Well, it'd be in quadrant 1 at pi over 3. And we're going to tell those numbers by looking at your unit circle. Okay, so that part shouldn't be hard. You got to figure out what these symbols mean, and that's what it means. Where is cosine 1/2 or inverse cosine 1/2? And tangent, inverse tangent is going to work just like sine. You can use quadrant 1 and quadrant 4 because tangent's positive in quadrant 1, negative in quadrant 4. That's why we use those quadrants. Okay, so one more time. Sine is 1 and 4 because sine is y. Y is positive quadrant 1, negative quadrant 4. Cosine, we're using 1 and 2 because it's positive in quadrant 1, negative in quadrant 2, which is all you need. Inverse tangent is 1 and 4 because tangent's positive in 1, negative in 4. That's why we're using those quadrants. All right, let's try a couple here. It says express both in radians and degrees. I didn't take a picture. I should have taken a picture of unit circle, but I'm just going to go through these really quickly. You can find these on your unit circle. So the first one is asking you, where is cosine square root of 3 over 2? Or it's really, you say it, inverse cosine square root of 3 over 2, but what they're asking you is, where is that? Where does that happen? And if you look at your unit circle paper, which I'm hoping you're kind of doing right now, you'll find out that that happens at pi over 6. Remember, if it's cosine and positive, you're using quadrant 1 only. So it's pi over 6. Also in degrees, it would be 30 degrees. Those are the same thing. Okay, part B. This is a weird one. Inverse sine of 2. If you look at your unit circle, look for where sine is 2, you're not going to find it because the biggest thing it can be is 1. So anything they ask you bigger than 2, if it's sine or cosine, it doesn't exist. Okay, you can't do that. There's no way. Sine and cosine are never bigger than 1. The value. Okay, so part C. Where's tangent negative square root of 3? Okay, because it's negative, I'm looking at quadrant 4 because it's tangent. Remember, sine and tangent, use quadrant 4 for negative answers. Negative square root of 3 happens at negative pi over 3. Or if it's degrees, it's negative 60 degrees. Remember, tangent's y over x. That's how you can find it. All right. I will show you another slide here in a second that has the unit circle on it, and I'll be able to show you a little bit more. But that's based on your unit circle and those values. All right, this one says solve the equation, and also gives a stipulation, which we'll talk about in a second. So when you see an equation like this one, and it says, where it's basically saying sine of what angle is negative 5/8. Take your calculator. I can just talk you through here. I hope you have it. Go ahead and get it. If you don't, stop this video, go get it. You hit inverse sine, which is second sine. Hit second sine, and your sine -1 pops up. Hit negative 5/8. Make sure your calculator's in degrees. And mine says this. Mine says negative 38.7 degrees. Okay, now that's quadrant 4. This right here tells me I want that answer to be in quadrant 3. Okay, so negative 38.7 is about right there. Okay, negative 38.7 is down there a little bit. 180 to 270 is over here. So I need to rewrite that angle to where it is over there instead of where it is right now. So it also needs to be 38.7 away from the x-axis. All right, so what I'm going to do is I'm going to add 180 plus 38.7. My count punch, you may hear me punching right now. And I get this right here. I get 218.7 degrees. Now what you can do to double check that is you can punch in sine of this number. I'm going to double check myself. I'm punching in sine of 218.7 and see what you get. Then punch in sine of negative 38.7 and see if you get the same answer, which you do. Okay, so pretty good thinking right there. So watch that again if you need to. Punch it in your calculator. All right, here we go. This is like the first slide a couple of slides ago where you're just finding values. Here's the unit circle. Okay, the first one right here, number 1 says find inverse sine of square root of 2 over 2. Remember, sine, you can use quadrant 1 and quadrant 4. So I'm looking for y. Sine is y. Where is y? Square root of 2 over 2 and quadrant 1 is right there. And so where is that? That's at pi over 4 and 45 degrees. And that's all you're going to do. Like, what are the measures right there? I know they are. All right, let's try the next one. Number 2. 2 says, where is cosine 1/2? Okay, if it's cosine, remember, for positive, for cosine, I'm using quadrant 1. If it's negative, quadrant 2. So where's cosine? Cosine is x. I'm looking for x is 1/2 in quadrant 1. There it is. So I'm just going to say, oh, it happens at pi over 3 and also 60 degrees. All there is to it. All right, tangent, number 3. Tangent, negative 1. Now, tangent is not x or y. It's y over x, which means if it's negative 1, x and y have to be the same value but have different signs. And because it's negative, I'm looking in quadrant 4. Okay, because tangent, remember, you can use quadrant 1 and quadrant 4. And they have to have the same value, y and x to get negative 1. And there it is right there. You see those y and x both have the same value. That happens at 7 power 4, but we can't put that. We have to put something, just put the negative. All right, so for number 3, we're going to write it this way, negative pi over 4, then negative 45 degrees. Your answer has to be between negative pi over 2 and positive pi over 2. It can't be like 7 power 4 or 5 power 3. You got to convert that just a little bit. We'll work on that tomorrow. Number 4, where is sine negative 1/2? Okay, if it's sine, it's the y. It's got to be quadrant 4. It's right there. I'm trying to circle. I got so much circles going on here. Where is that? It's at this. It's 11 pi over 6 and 3/30, but you can't write it that way. You just got to go negative angle when you're doing the inverse sine or tangent. So I'm going to put negative pi over 6, which is where we are, and also negative 30 degrees. Okay, instead of putting those big numbers. Your answers, once again, your answers for sine and cosine, sine and tangent have to be between negative pi over 2 and positive pi over 2. That's where your answers have to be. If it's cosine, it has to be between 0, sorry about that, and pi. Okay, one more slide here. All right, the last thing is going to be find what the angle is. Like, figure out what in the world that angle is right there. And if you don't know the angle, anytime you're looking for an angle, it's always inverse whatever, inverse sine, inverse tangent, inverse cosine. So use what you know. This time I know the opposite is 5 and the hypotenuse is 12. So I know the opposite and the hypotenuse. So, oh yeah, that's sine. So I'm going to do sine of theta equals opposite over hypotenuse. So in my calculator, all I'm going to do is punch in second sine, inverse sine. That's what answers that. If you don't know what the angle is, do second sine, and you're going to punch in 5/12, close your parentheses, and you get this angle right here, 24.6 degrees. I wish you'd punch that also, make sure you get it. And that's what the lesson is going to be. I'm actually going to work on this for 2 days this week because it's that important. All right, so do the best you can today. We'll work on it some more tomorrow. I'll see you there.